We're going to take a field trip to Stone Mountain. We are on the east side of the mountain, the opposite side of the walk-up area. This area was used to mine dimension stone, large chunks of rock used for buildings and monuments. The quarry was utilized from the mid-1800s to the late 1970s. This quarried rock was carried out by railroad, and some of that railroad track is still a part of the tourist attractions at the mountain. Stone Mountain is one of the largest exposures of granite in the world. At the base of the mountain, notice the dome shape. This was created through a weathering process called exfoliation. The mountain is considered an exfoliation dome, or otherwise known as a monadnock, a hill isolated above a plain. Stone Mountain is not a true granite, but is called a quartz monzonite, an intrusive igneous rock composed of plagioclase and albite feldspars and between 5 and 20% quartz, with a little specks of mica thrown in as well. Quartz monzonites are clues that melting occurred in ways different than most melting occurs on Earth. Most granites are actually grandiorites, which don't have enough quartz in them to be a true granite. These grandiorites typically form by magmas cooling above subduction zones. Recall that subduction zones occur when converging tectonic plates of differing densities collide. The more dense of these plates will go under or subduct underneath the less dense plate, creating heat and magmas. Here we see a good example of a cross-cutting feature known as a dike. Dikes form when the hardening quartz monzonite cracks, and hot liquids from underneath seep into those cracks and harden. These are composed of a true granite, which includes mostly alkali feldspars, but with more than 20% quartz and lesser amounts of plagioclase. Moving over the mountain, let's look for another dike with slightly different composition. As we move across the base of the mountain, we come across another dike. Similar dikes can be found along the walk-up trail. These dikes were formed by water-rich fluids, which circulated through cracks that formed on the outside of the cooling magma chamber that formed Stone Mountain. Notice how plants are filling in pits created through a chemical weathering process. Most weathering on Stone Mountain is created by plants, especially tree roots, and are readily seen along the walk-up trail. Continuing up the mountain, we still notice plants growing out of cracks and weathered pits. Also notice how the dike continues up the mountain. There are also dark patches. These dark patches that we see are not necessarily due to water stains, but are more due to lichen growing on the rock. As we move around the mountain, we can see more dikes, as well as evidence of additional weathering that has occurred. As we walk past the edge of the wall of the quarry, think about the large slabs that were removed using dynamite, drills, and saws. These slabs were shipped all over the world and used in many buildings and monuments that still stand today. We know that the dikes we have seen must be younger than the surrounding rock, since they cut through the rock. The rock had to have already been there in order for the dike to have cut through. But sometimes you can see rocks inside of rocks, indicating inclusions, which must be older than the rock that surrounds it. These occur when rocks on the sides of magma chamber fall inside the chamber. These are called xenoliths. Here is a good example. So, let's talk for a moment about this xenolith. Notice the bands of light-colored quartz and feldspar and dark biotite mica. This is a metamorphic rock called gneiss. It's a foliated rock, which means it has these ribbon-like layers. This is the same type of rock that makes up Mount Arabia. This gneiss melted approximately 290 million years ago, which produced the magma which formed Stone Mountain. The gneiss began as a sedimentary rock on the seafloor about 1 billion years ago. Heat and pressure from underneath the forming Appalachian Mountains changed the rock. As we continue our tour of Stone Mountain, we have now moved across the street from the rock quarry, just down a couple of 100 yards on the other side of the street near the grist mill. Notice that this is a gated road, a private driveway. Don't try to enter this area unless you have permission from the Stone Mountain Memorial Association. This is Old Highway 78, which used to be the main highway running past Stone Mountain. This was long before the 4-lane highway that you drive on now. You may remember the duck boats that used to be at Stone Mountain. This was the access point to the lake. To build this road, portions of the Stone Mountain granite were blasted through, and this exposed an area of very weathered rock. The minerals in this rock have turned to clay while preserving the texture of the rock, but it will continue to weather into soil. So if you were a geologist studying Stone Mountain, what might you be looking for? Well, one thing you would be looking for are called contacts. These are places where rocks of one characteristic meet rocks that have another set of characteristics. In looking for these contacts along Old Highway 78, we can see breaks in the granite where it is weathered, but this is not considered a contact. So as we continue moving along, look for distinct changes from one rock to another. Here is a contact where the white rock meets the red rock. If you examine a smaller rock from this area, notice that it has oxidized on the exterior while the interior is very fine-grained. This is an extrusive igneous rock called basalt, or diabase. It is very fine-grained because it had a rapid cooling rate, not allowing larger crystals to form. These formed on the surface in very shallow intrusions from eruptions about 200 million years ago. These solidified into dikes, which cut across the Stone Mountain quartz monzonite. This created large lava flows as North America and North Africa were diverging at the start of the Jurassic period. These diverging boundaries created a decrease in pressure, resulting in the melting that occurred. Remember, melting occurs by decreasing pressure, increasing heat, or adding water. These particular melts led to the formation of basaltic magmas, which contained large amounts of sulfur dioxide, which can lead to climate cooling and the formation of toxic sulfuric acid. This, combined with an asteroid strike on the Yucatan Peninsula, is what doomed the dinosaurs. Finally, as you walk around Stone Mountain, notice all of the examples of exfoliation, which is the peeling away of sheets of rock from millimeters to meters in thickness. Cracks go into the mountain and layers of rock pop open like an onion as material is eroded from above.